What if I told you there's a shortcut through the universe, a cosmic tunnel that could take you from one side of the galaxy to the other in the blink of an eye? Sounds like science fiction, right? Well, today we're diving into the mind-bending reality of wormholes. Could they actually exist? And more importantly, what would happen if we tried to travel through one? First off, let's get on the same page. What exactly is a wormhole? Imagine the universe is a giant sheet of paper. To get from point A to point B, you'd have to travel all the way across the surface. But what if you could just fold the paper, bringing A and B right next to each other, and then poke a hole through them? That hole is your wormhole. It's a theoretical passage through space-time that could create shortcuts for long journeys across the universe. The idea comes straight from Einstein's theory of general relativity, which tells us that gravity is the result of space-time being curved by mass and energy. So, in theory, an extreme enough curve could create a tunnel. The concept was first explored by physicists Albert Einstein and Nathan Rosen in 1935, which is why they're sometimes called Einstein-Rosen bridges. They imagined these bridges connecting two different points in space-time. But there's a catch, a big one. The original Einstein-Rosen bridge is incredibly unstable. According to the math, it would pinch shut the instant it formed, trapping and crushing anything that dared to enter. Not exactly a five-star travel experience. So how do we keep the wormhole open? This is where things get even weirder. To stabilize a wormhole and make it traversable, you'd need something with very unusual properties. We're talking about something called exotic matter. This isn't just matter that's rare or from another planet. Exotic matter is a hypothetical substance that has negative energy density. In simple terms, while normal matter pulls things together with gravity, exotic matter would push things apart. It would act as a kind of anti-gravity, propping the throat of the wormhole open and preventing it from collapsing on you. The problem? We've never actually observed exotic matter. It's purely theoretical, and we have no idea how to create it or if it can even exist in the quantities needed to sustain a wormhole. But let's be optimistic. Let's say we find some exotic matter lying around, or we become a super-advanced civilization that can manufacture it. We build our stable, traversable wormhole. What's next? You bravely volunteer for the first trip. What would you experience as you approach the entrance? From the outside, the mouth of the wormhole might look like a shimmering, spherical distortion in space, like a crystal ball reflecting the entire universe. As you get closer, you'd see the light from the other side, the destination, getting brighter and larger. It would be a breathtaking, disorienting window to a distant part of the cosmos. The gravitational forces at the entrance would be immense, so your spacecraft would need some serious tech to avoid being torn apart by tidal forces. The same forces that cause tides on Earth, but ramped up to an unimaginable degree. Now you enter the throat of the wormhole. What does it look like inside? The answer is, nobody knows for sure. It's a region where our current understanding of physics completely breaks down. Some theories suggest it would be a chaotic, turbulent journey. You might be bombarded by high-energy radiation, particles, and even light that gets trapped and amplified inside the tunnel. It could be like flying through a cosmic particle accelerator. Without some seriously advanced shielding, the trip would be instantly fatal. Other physicists, like the renowned Kip Thorne, have a more optimistic view. Thorne, who was the science advisor for the movie Interstellar, proposed that a sufficiently advanced civilization could clean out a wormhole, making it a calm and safe passage. In this scenario, the journey through the throat might be surprisingly quick and uneventful. You'd pass through the tunnel and simply emerge on the other side. One moment you're near Earth, the next you're in the Andromeda Galaxy, 2.5 million light-years away. The entire journey could take mere minutes or hours from your perspective. But here's where it gets truly mind-bending. Time travel. Because wormholes connect two different points in space-time, they don't just bridge distances. They can also bridge time. Let's say you have a wormhole with two mouths, A and B. You keep mouth A stationary near Earth, and you put mouth B on a spaceship that travels at near the speed of light for a while and then returns. Due to time dilation, a real effect predicted by relativity, time would have passed much more slowly for mouth B. So now, when you look through mouth A, you're not just looking at a different place, you're looking into the past of mouth B. If you step through from mouth B to mouth A, you'd travel into your own future, and if you go from A to B, you'd travel into your own past. This opens up a whole universe of paradoxes. What if you go back in time and prevent your parents from meeting? This is the famous grandfather paradox. If you were never born, how could you have gone back in time in the first place? Physicists have proposed solutions to this, like the Novikov self-consistency principle. It suggests that the laws of physics will always conspire to prevent paradoxes. Any action you take in the past was already part of history, so you can't actually change anything. You might try to stop your parents from meeting, but you'd fail in some unexpected way. Maybe your actions are the very reason they met in the first place. You become a part of a consistent, unchangeable timeline. Another possibility is the many worlds interpretation of quantum mechanics. In this view, traveling to the past would cause the timeline to split. You would arrive in a parallel universe, a new timeline where your actions have consequences, but it wouldn't affect the original universe you came from, so you could do whatever you want without creating a paradox in your own history because you're now in a different one. So to recap our journey, to travel through a wormhole, we first need to find or create one. Then we need to stabilize it with vast amounts of hypothetical exotic matter. Our ship needs to withstand extreme gravity and radiation. If we manage all that, we could travel vast cosmic distances in an instant, and as a bonus, we might even unlock the secrets of time travel, either becoming part of a fixed loop of history or branching off into entirely new universes. Right now, wormholes remain firmly in the realm of theoretical physics. They are fascinating mathematical possibilities allowed by Einstein's equations, but we have no evidence that they actually exist in our universe. Finding one would be a monumental challenge. They would likely be microscopic, left over from the Big Bang, or require energies far beyond our current capabilities to create. But never say never. 100 years ago, black holes were just a strange prediction of relativity. Now, we've photographed them. The universe is filled with mysteries, and the gap between science fiction and science fact is always shrinking. Perhaps one day our descendants will look up at the stars, not as distant, unreachable lights, but as destinations just a short hop through a cosmic tunnel away. The possibilities are as vast and exciting as the universe itself. Thanks for joining me on this journey through space-time. If you enjoyed this cosmic exploration, don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure into the unknown. See you next time.